Let's take an example of carbon atom. We know carbon has atomic number 6. So its electronic configuration will be 1s2, 2s2 and 2p2. In ground state, its orbital representation will be, in s orbital we know there is only one subshell, and in p orbital there is three subshells. When a carbon atom goes into the excited state, its one electron will transfer into its p orbital and all the four orbitals become half-filled orbitals. As we all know, carbon forms three kinds of compounds: alkanes, alkenes and alkynes. In in alkanes there is carbon carbon single bond. In alkenes, there is carbon-carbon double bond, and in alkynes, there is carbon-carbon triple bond. When carbon-carbon single bond is present, that bond is only a sigma bond. With carbon-carbon double bond in alkenes, there is one pi bond and the other one is sigma bond. And in carbon-carbon triple bond, there is two pi bonds and one sigma bond. And according to the presence of pi bonds, these both carbon compounds will gain partial electronegative character. This character I will explain you according to the hybridization. Now, what is sigma and pi bond? According to sigma bond, there is always head-to-head overlapping. There is an overlapping between two s orbitals, and if there is head-to-head overlapping between p orbitals, then it will overlap like this: p and p orbital, and these two are of kind sigma bond. And in pi bond there is always a sidewise overlapping. It is a pi bond. And according to these three diagrams, it is observable that when the bond is formed with sigma bond or sidewise overlapping, there is more extent of overlapping which makes sigma bond a stronger bond. While in pi bond, there is always a sidewise overlapping which makes it lesser stable than sigma bond, and this pi bond adds to the electronegative character. And when the bond formation occurs, this pi electron will participate in bond formation. Now let's take a look for the formation of or hybridization of the carbon compound. Let's start with the hybridization of alkanes. As I have told you, the carbon in its excited state has one electron in each of the four valence subshells of it. Let's take an example of alkane, be methane. By methane means its chemical formula is CH4. When hybridization occurs, now atomic number of hydrogen is 1, so its electronic configuration is 1s1. There are 1 electron of carbon in each subshell. Now let's add these 4 hydrogens in all these 4 subshells. So this is hydrogen, this is hydrogen, this is hydrogen, and this is hydrogen. It is carbon's 2s1 orbital and hydrogen is 1s1 orbital. It is carbon's 2px1, 2py1 and 2pz1 orbital. And the hydrogen's orbital is 1s1, 1s1 and it is also 1s1. Now look, there is intermixing of different orbitals. It is 1s orbital and it is 2p orbital. Clear? And what I had told you about the definition of hybridization. Hybridization is the intermixing of different orbitals in a compound. So how many orbitals are taking part in the hybridization? 1s and 3p orbital. So its hybridization is 3sp, 3 hybridization. Clear?